discuss how to build these kind of systems. Okay, there are multiple options. We will discuss key what is being used by majority of the companies and what you should present during interview. Let's open up a diagram. Okay, everyone please put your entire attention. Dekho, initial understanding is very simple, okay, but as you get into the use cases, a bit tricky complexity might start coming up, but initial understanding is very simple. So let's go with the initial understanding first of all. Okay, so let's say we have microservice 1 payment. Let's say we have microservice 1 payment validation service. We know that under payment validation service, we have these many number of property files. Okay. We have these many number of property files. Similarly, now we have another one as well, which is Stripe provider. This also guy is having these many number of property files. Now, just imagine we will have many more in future. Now, what is going to happen with Spring Cloud config related? We need to create, so this is microservice 1, this is microservice 2. So we need to create a third microservice. And this is going to be called as a config server. A new microservice we have to create. Microservice. And we can name it as, let's say, payment config server. A separate microservice we need to create. New jar POM dependencies, starter dependencies will be there, which will make this as a configuration server. And the aim of this configuration server will be all of these property files you can move. All of these property files you can move here. So you don't have to maintain it in your local microservices. All these property files will be maintained here. So you can just imagine, instead of having all these files in your local microservices, you can save everything in a separate place and you will get it from a config server kind of tool. So you don't need to have it here. You will simply delete this. You will simply delete this. In your microservices, you will not have any configurations. Only application.properties you will keep here, because port configurations, those basic things you might need. So you will keep only the first one here, but all the rest of the things, you will delete it from your local place and they all will be available here. That is the point number 1. Okay, in order that, now when the microservice environment is starting, profile concept remains the same. So we will be having Spring Profile active, profiles.active. Let's say if you say I want to activate QA profile. So whatever we discussed about profiling, that remains the same. But now what is going to happen? Whenever you are starting this payment validation service with a QA profile, you will not have this QA file with you in your project. Rather, it is going to be available here in the config server. Your microservice should be able to connect to this configuration service and read the corresponding QA property file. So that means runtime paid different behavior. When you're starting your microservices, now you will need to connect to external system to load the configurations, and which file to pick, that will depend upon your profile only. So the way we have profile that chooses from local, now it is going to choose from cloud place. That's it. So in order that microservice should be able to do that, we say these microservice, we need to enable them as config client. So there are two concepts here. One is a config server, which is responsible for providing you the configurations. And then there is a config client, which will connect to the config server and get the needed property. And then you can use it. Rest of the thing is similar, like @value, and you can use it across your project as well. So this is the main approach. What is the main approach? You don't keep the property file in your local, rather you keep it externally someplace. And not just one microservice, all your 20 microservice will not maintain any configuration. You just move everything into a separate place. Second, your microservice should now behave like a config client. So whenever they start, depending upon your profile, you will connect to this configuration server and read that property file, accordingly reflect it into your Spring Boot application. So that is the approach. Let's make a quick note about it. Let's make a quick note about it. Okay, how to build config, how to work with Spring Cloud config. Okay, step number one, you need to add a new microservice called as config server. Step number two, all your environment specific properties files from all microservices needs to move to this config server. Okay, step number three, all your application microservices, because this is a configuration microservice. Now, other services I'm calling it as application microservices. All your application microservices should behave like config client. Why it is required? So that during startup, they can connect to destination config server and load the properties. Okay, which property file to pick from destination? Same Spring profile concept. Okay, application microservices will use the same Spring profile concept to decide which which property file to load from destination config server. Guys, take a minute to absorb this high level strategy. So we will not create any configuration files here. Rather, everything will be created here. How will it look like? Let's update this diagram. So I'm copying this everything. And then we can have a different version of diagram here, where now you will keep only application hyphen local here, but these all application hyphen properties here, and all these other configurations, we need to move it here somehow. Okay. Similarly, this is also available. We need to move it here. But now look at the practicality. Currently, all these property files have the same name. How do you differentiate in the config server ki which configuration file means which microservice? Differentiate that. Okay, there are multiple ways of doing it. Simple, straightforward ways. Okay, listen to this part very carefully. Whenever you define a payment validation service in the property file or any kind of microservice, in the application.property, we use some key called as Spring application name. Nothing but with this name, this microservice can be identified. Okay. So there is a property called as Spring application name, which helps us to give some name to this particular microservice. So this name is payment application service. So what the recommendation is, while you save these property files inside the config server, because now like this 20 microservices are going to give it, okay, you need to change the naming. Okay, you need to change the naming, something of this format. Spring dot application name hyphen local dot properties. Nothing but in this case, now this configuration is going to then change. This configuration, file names, we are going to modify all of that as per this new decision making. It will become this, it will become this, because some differentiation is required. Okay, so this becomes the new file names which will reside in the config server. So we cannot keep it like this as it is because it will all clash. So instead of keeping it like this, we will be keeping it with a different naming like this. Similarly, for this one also, the configuration is going to now be different. It will be called as whatever Stripe provider service, whatever is the name of the application name, Stripe provider service hyphen local. And this goes like this goes like this goes like this goes like this. So naming wise, we need to be clear. So we need to save it in this particular manner. Okay. So again, this will not be applicable and we will be saving it like this. So guys, that is the second change. Let's make a quick note of this. As all the config files of all environments will be saved centrally, so we need to name it clearly for identification. So what we can choose the naming? Spring application name, and then we further specify what environment it is dealing about. Okay, so then we further specify what environment we are dealing about. Like this. This is the environment. That's how the configuration will be. Now, just I think you might be knowing, apart from properties, there is another way you can set up a .yaml. So same discussions apply even for YAML configuration. There are two formats of saving configurations. One is .property file, which we are using right from the day one. Sometimes project might use YAML. It's just structurally different, but basically both does the same thing of configuration management. So that is the next point. So while saving here, we need to have it in a proper naming. Okay, fine. That's the next thing to understand. And this part is already clear. During service startup, this so I think we should just move these two things a bit here. And this is anyways going to go this side, so it becomes more readable for us. Likewise, we can move even this piece and include this one here. Okay, fine. So this is how it is going to be named. Okay, fine. Guys, so far clear, right? Everything is very straightforward. Are we clear with this? Properties should go there. It should be named properly. Then only other microservice can read it. Okay, very good. One more point we discussed, it should become like a config client. So we already mentioned that point also. Okay, chalo, thank you for confirmations. Let's discuss the next point. We will now do it all practically, but first let's understand the concepts. In the config server, how can we save these property files? Let's discuss about that for a moment. Okay, let's say currently these property files have some value, key equal to value, and you are saving all of them in this config server. Where do you keep it? It is also a microservice. So one of the option is where you keep the config files in config server. That is the next topic that we are discussing. One option is project class path. Nothing but we know that SRC main resources, this belongs in the project class path. Under this SRC main resources, we might create a dedicated folder saying .config, and all of these property files star.properties will be available under this config folder. This could be one of the setup, but people don't use this setup in production. Only for testing purpose, people might prefer this kind of option. Why? Let's discuss that. But first option is you can put all the property files inside the project class path, nothing but under this src main resources, which is part of the project class path. You can create a new folder, and /config is the default folder also, if you are choosing to keep it in class path. And under that, you can put all your property files. So let's say all 200 files, you can put it here. Now, in future, if more files are coming, like 200, further more subfolders can be created. But let's go with the initial level. All the files are available inside the same config folder, and they will have these kind of namings, so you can identify which environment, which microservice we are talking about. So everything will be under the config folder itself. Okay, this is one approach. We can make the changes, but what is the problem with this approach? Simple problem with this approach is, every time you want to modify the property, what are you supposed to do? You are supposed to go to the source code of this project, update the file values, whichever file it is. Again, it has to be built, restarted. Means it is painful. Configuration changes are not easy if you keep these files at the class path level, because you have to again modify it. So if you're choosing this kind of approach, the problem with this approach is, each time you want to change any values, you need to modify in project code, build, deploy. Nothing but restarting will happen, and then other guys will get their new changes, which is again not a practical solution. We are trying to build a good configuration management system and still having problems, so it is not a good option. But yes, please be aware, one of the way you can simply use is class path based setting, which will be like this. But there are problems with this. What is the second solution? Second solution, you can keep it in the file system. Keep it in file system. Okay, nothing but, let's say this config server is running in my local machine. So this config server is running in my local machine. So what I can do is, in my local machine, I will have some other folder, maybe D drive apps /config folder. Under this config folder, we will put all the properties file. Okay. And then when your Spring Cloud config server comes up, it will read from this property file. Okay. It is going to read from this property file. That is the second option. So if you want to do any modifications, no problem. You directly go to the file and you change the values here, you save it. Config server don't need to change the code, no need of build, no need of deploy. Runtime, it is going to read the latest values from this. Automatically, life is simple. So second option is better, keeping it in the file system. So you have to be very careful when you are running this configuration server in the whichever environment. So there you need to be like, wherever this service runs, on that EC2 machine, in some folder, all the configurations you can keep. Okay, this could be one of the approach. Or you can keep it maybe in a S3 bucket somewhere, one more place, and from there you can read also. But in some file system you are keeping, and config server then will not have to make any changes into its own code. That is a better version than using a class path based solution. So let's discuss the second approach here. Keep it in class path. So let's say wherever your config server is running, on that machine, you can choose to create a folder let's say D drive config, and here you can put all the star dot properties. Okay, your config server will read these properties, okay, and serve to config client. Just be clear with terminology: config server, config client, properties, configurations. Okay, use it very carefully. So your config server will read these properties and serve it to the client. Advantage with this approach is, if you want to make any changes to these properties, okay, just update the files and save. No need to build, restart the config server. Okay, just by saving the files, config server will be able to read the new changes and serve it to the client and share with the client. That is the approach number 2. This one is better than keeping it in the class path. Nobody keeps it in the class path in production. However, some people might choose to keep it in file system in the production environment. Okay, guys, are we clear with this? Team, are we clear with this? Please give a quick confirmation. During interview, they might discuss, and this is a good value add. You can include this also in your resume. Worked with Spring Cloud config, and all of today's discussion will be helpful for that. Okay, very good. Thank you for confirming. Now, there is one problem with the second approach also. So this is not the best approach of managing or keeping the configuration. Simple problem here is it doesn't have tracking, right? Anybody coming, making whatever modifications, it's not tracking changes. If something went wrong, reverting back to the previous change, because you're directly modifying the property file in the local system. That history tracking, who has done the modification, when the modification was done, if you want to revert back to the previous stable version, all that control is not there if you use approach number 2. So it gives some advantages, but it has problems also. There is zero tracking, zero version maintenance, zero rollback capability. Accidentally, if something goes wrong, blunder happens. So for that reason, many people will say, no, 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 don't use the file system approach also. And these are very serious problems. Think about it. Who is doing what modification if you don't have the track? Accidentally, if some property file get deleted, we will not even know who has done that kind of accident also, right? So that is the major drawbacks why people will not choose file system based approach also. Okay, major concerns. At least with first one, that problem is not there, class path, because it is going to be saved in Git only. Your project is fully available in Git itself. So if any changes happen, it has to be committed. So we will know who is doing what modification. So, but in the file system, major concern with this approach is no tracking of who has done what modifications. Zero tracking available. Rolling back capability, rollback to previous stable version. These things are really very hard. So for that reason, companies are really hesitating. No, without having this control on what is happening to configuration, better to not use file system approach also. Then what do people do? Where do they keep it? The most common practice in a config server, okay, where you will keep it, is this third solution. And this one is the recommended approach. You keep the configurations inside Git repository. Git repository. Nothing but, let's go back to our diagram. Instead of keeping these things in the same machine or inside the microservice, so class path means inside the microservice. File system means inside the machine where this is running. No, now the solution says, keep it in some other repository in cloud. Nothing but a Git repository. What we will do is, we will create a separate Git repository, and maybe we can call it as, maybe we can call this Git repository as, let's say, config repo or config properties. Simple. A new Git project we will need to create, Git project. And all of these property files that we have will be kept inside this Git repository. It will not be there in your config server. It will not be there in your file system also. It will be kept somewhere else. And then we will do some setting in the configuration server to runtime connect with this repository and get the changes. This is the recommended approach which majority of the company follows. What is the flexibility with this? Basically, you get all the flexibility. First, central configuration management you are getting. Second, versioning and control tracking. Who is doing what modification? Everything is very precisely tracked. Accidental mistakes cannot happen. Third, developers are not bothered. Because it is only configuration. There is no Java code or any programming language code. This repository will have only property files. That's it. So even a DevOps guy or a non-developer can access it and just its key values. Anybody can read it, modify it. So DevOps can work independently from it. So many advantages just comes because of these things. What are the advantages? Git repository. What are the advantages? All configs are centrally available. Next, version tracking is possible. Version tracking, rollback, all of those things are possible. Okay. Next, directly DevOps can work with this changes. No need to involve the developers as part of the journey. So ease of so many things are happening. Another thing, you can directly modify these things the way you were modifying this. It does not need config server restart. So that another advantage is still there. You can directly modify the values in Git and no restart of config server. Config server will pick the latest value and behave accordingly. So these are the advantages of keeping it inside a Git repository. Now, depending upon, now one of a common practice of keeping our entire project source code is in Git repositories in the current time. Now, whichever approach you follow, so let's say our current project, everybody is keeping all of this information in Bitbucket. We maintain our cloud hosting provider as the Bitbucket. Now, depending upon what provider choice you are doing, you have the options. You can keep it in Bitbucket, or you can keep it in GitHub, or you can keep it in GitLab. Okay. So whoever Git provider is available, you can keep this as a Git repository in any of that, and then make the changes in your application to connect with it. Okay. So we are going to, for our demonstration, we will be keeping it inside Bitbucket, these configurations. And then we need to have a config server, which should be able to connect to these configurations. And then somehow the changes should be loaded to these guys behaving like config clients as well. So this is what is going to be the production scenario for us. And during interview, you should give the same clarity that in Bitbucket, we created a separate repository called as config repo, and there all the configuration files are planned to be put. We have another project called as a config server project, and which is going to connect to that, and then the values will be available, and all config clients go here and get the value. So guys, this is the big picture of a working solution of config server. Guys, are we clear with this? Are we clear with this, guys? Everybody, are we clear with this? एक काम करते हैं, everyone, please open up your notepad. 2 minutes के अंदर, whatever you are able to think, if somebody asks, okay, tell me something about Spring Cloud config, whatever thoughts come to your mind, write it down. 2 minutes. Whether it is done or not done, 2 minutes. Let's see what you are able to think. Okay, chalo everyone. A 2 minutes timer, and then we will continue with implementing this system. Whatever comes, I will keep the diagram in front of you, so maybe some thoughts can move in a direction. Anything which comes to your mind. There is one more topic, we will discuss that, and then we will start with the coding. Think what main points you are feeling advantages with Spring Cloud Config. It's all about configuration management, ease of configurations. And as the project grows, this is not optional, it becomes important. 200 files, who can manage 200 files? Somebody says modify this property and you're using it across entire repositories. Baap re. One by one you have to check out feature branches, make changes. It's a painful activity. Okay, so you will feel this is a must-have solution. And as the project grows, small projects, few microservices, less than 5 people will live without all these things, no problem, and which is fine. Why are you overcomplicating, right? 2 additional repositories, unnecessary client and server communication. If your system don't need it, don't add the complexity. But as you grow, this becomes a savior rather than the problem, right? That is what it is. Chalo guys, everybody, once you're done, please give a quick thumbs up as well. 15 seconds to go. At least few bullet points, whatever comes to your mind. Config server capability. Okay, Ajit is done. Okay, Sandhana is also done. Okay guys, 2 minutes time up also done. Chalo, fine. Let's go further. Now, one thing you understand here, and this is what is a bit tricky part for beginners to really catch up. So focus. How this entire setup is going to be there with regards to multiple environments. Okay, let's check it out. Okay, so first of all, this Git repository will have all the configurations for all the environments. So this is also a Git repository, but here you don't need a very big branching model the way we have in our master branch, integration branch, feature branch, release branch. That kind of drama is not required, because in one place itself you are maintaining everything. So general practices for branching models will be different when you are operating with this Git repository. You will just create main branch, which is the default big branch available. You will just create a main branch, and whenever you want to make any modification to any of these property files, one approach is going to be, you will create a feature branch out of that directly. Okay, you will directly create a feature branch out of that, make the modification, raise a code review request, and put it back into the main branch. That's it. You don't need a very big hierarchy in this case, because you are just keeping it central. Again, some companies might follow different approaches of branching model. They might say directly in main branch itself, keep committing. Some companies might still say, no, keep it similar to what we have, main, integration, or feature. But ultimately, it is one place change. So the simplest model could be just have a main branch. Whenever you want to modify, cut a new feature branch out of it, raise a pull request so that code review can happen for your changes, and then somebody approves your changes also, and then you can move it back into the main branch. And whenever this service is trying to connect, you will make sure you connect to the main branch. Okay, so we need to provide that kind of configuration here. They will connect to the main branch itself from this place. So that is one thing to understand. Okay, what is that point? The config repo might follow a different branching approach than rest of the application repos. Why? Because DevOps might directly work. They will be like, come on, what is all this complexity of integration, this, that? I just want to modify the file. Give me an easy way to do. So we can choose to keep a simple configuration there, which is nothing but have only main branch or master branch. And when wanting to make modification, create feature branch, change it, and pull request to main, your code review will happen. Code review, those things, don't try to skip. It becomes a problem if something goes without a review. So code review, then main, and your config server will load values from main branch itself. So you don't have to worry about always changing into feature branches, and every time config server should point to a new feature branch. What's of drama is not there. You will define it in a static manner. You directly connect only to the main branch, and here you will manage everything at one place only via pull request strategy. That is one thing to understand. Second, let's discuss about config server. Generally, setting up the config server is also a one-time activity. It is not going to have any much coding. You will not do any kind of application coding. It will have very simple thing. Making your microservice a configuration server is a one-time activity. Next, pointing to these other GitHub places and maybe other configuration, everything is a one-time activity. Nothing but sprint by sprint, you don't have to modify these things. So sometimes what people will say, you finalize one branch itself, main branch, and from there itself, all the code will run. Okay, nothing but let me just simplify things for you. How this service is going to be managed. Okay, for dev environment, let's say this is a dev environment, we will have this kind of a setup. Dev environment will have one validation service, one Stripe provider service, and one config server instance will be running for the dev environment only, which points to this Git location. Now, if you go to QA environment, there also these things will duplicate. So there will be application service instances running, plus one config server instance is also going to run inside QA environment. So don't think about we need to have only one config server and all the environment property like services will connect. No, a general practice in production is for general practice in the infrastructure is in the dev environment, have the dev configuration server. When you are running in your local, have your local configuration server. When you are running it QA, have a QA configuration server. But basically, all the code everywhere will be the same. Everywhere, the code will be same, and that code is going to just talk to this Git repo only. So you don't worry about maintaining different code anywhere, it stays same. But what is the input here? In every environment, one config server instance should be running, and that talks with the same central place, because these things are environment specific and you don't need much branches. Finally, you get everywhere the same. So just have a main and then connect with that. So what is the second learning here? What is the second learning? Okay, one config or config server instance will be running in each environment, which is nothing but local dev QA UAT prod. Next, they all has same code. Okay, code to connect with destination Git repo to load all configurations. But still, we will run multiple instances, not trying to really get everybody to the same one, because there are multiple environments involved. Okay? So please be aware of these two changes. And now it's time we start coding this system. Okay, everybody, please put your full attention. One by one, we will be coding. Already I have put in the required changes into one central document. You can go to ChatGPT and start exploring one by one as well, and then apply. Okay. To start with, I have created a getting started project. First step is I've created a getting started project, just like all of our other microservices. Getting started project for payment con config server. So somewhere it will be like this: payment config server. So this getting started project, we will be doing setup, making the changes and going further. Okay. Chalo, one by one, let's do it. So what I will do is, let's create a new folder here. Okay. Feb 26 config server explore. This is only for our naming. I am moving this getting started folder into this, so we can focus on one. Just like any other repository, we need to follow the same. We need to set up a repository into the bit bucket, import it into our project and use it there as well. So what I will do is, first let's explode this, right click, extract all. Let's just get it here. Okay. So fine. This is the getting started source code. Now what is required? We need to go to Bitbucket. This we have already done with validation service and Stripe provider also. Let's go to what? Project, Feb 26 CT, repositories. Now we need to create a new repository here. So let's do that. Create a repository. Okay, what is the repository naming? We will say somewhere payment config server, and let's just put our Feb 26 CT. CT is for career transformation, and let's choose it in a Feb 26 project. Repository name is like this: payment config server, and then we go, it's a private repository. Create. Now for this, you can follow a branching model like integration, main branch and integration branch. You can do that kind of branching model. Okay? But anyways, you might set up this once and for entire 1 year not make any changes. Okay? But anyways, for these, this is also kind of a functional microservice. Here you can follow your rest of the branching model. If you need to make a modification, cut a feature branch from integration branch, in the QA environment integration. So config server, you can keep same branching as your rest of the application. Only repository ka you change on the branching model. Okay? Okay, fine. So now what are we going to do here? So main branch is there. We will just create a integration branch out of main branch. It is other type of branch. And directly in this integration branch, let's do coding. Okay. So I will be checking out this in source tree. The first setup we will directly do it in integration branch itself. Here we go. What is our location? D drive, not like this. Let's try to go from this place. Under repo folder, we need to go. Repo folder. And here we need to have our new repository code for config server. So here we go. And here we say like this. And then we specify hyphen, okay, config server integration. Okay, payment config server integration. And then clone it. We are just setting up a Git repository to work with config server. Okay, so we are there, and this is the integration. Git is available. Next, whatever you checked out earlier, exported the zip file, I will be uploading it in Google Drive today. So we will just take all of that getting started code and move it here. Replace the Git file. Now make sure we work with this. So take it, import it into your IDE, and the config server code will be ready for us to work with. So import existing Maven project. This is the one. Give the same naming here and then finish. Okay, this becomes the code for config server. Let's try to build it once. Right click, run as, Maven build, clean package. Maven build, clean package. Okay. Currently, it is just like any other getting started, having one main method related application startup file, having something temporary, just addition controller like we always have. Under SRC main resources, only application.properties are there. This is a common practice. For config server, port generally people uses 8888. Okay, so please be aware. Config server port generally will be 8888. Okay, so config server port, default port, generally people prefer like this. And some application name we have given payment config server. Okay, okay, that's it. Pom.xml is having some basic dependencies only, nothing fancy here. So we have same Spring Boot version like all our other microservices. Try to keep it consistent so version conflicts and problems don't happen. So otherwise you might struggle there. Next, it needs to have web dependency. Why? Simple reason. Internally, config server, okay, when config client is trying to talk to config server, they talk based upon API. So we don't have to do much coding for that. Internally, config client is going to make an API call to this one. So in order to support that kind of an API, web dependency is needed for config server. So please be aware, these are some basic things about config server. Okay, config server, you need to have this as the port. Next, second thing is have web dependency plus config server dependency. These two things needs to be added. Okay, fine. Chalo, one by one, let's keep doing that. So, but yes, we have done that. Remaining some dev tool dependency, Lombard dependency is there, and just some getting started Maven plugins. Okay, so nothing, it's just a getting started project. Let's quickly test it if the current code is working as it is. So right click, run as Spring Boot app. Okay, port is 8888. Let's try to go here, and we will be doing localhost 8888 /add and some numbers. Okay, it is coming. Okay, localhost add a number. So basically it is working. So what we will do is we will be committing all of these changes, whatever we did, saying ke initial draft of getting started code for payment config server. These are the regular actions. We do it every time. That is where I'm not explaining it again. I'm just performing it because we have done it multiple times already. Okay, so fine. Initial getting started code is there. It is working. Now we don't need the add method controller here. We can simply delete it. It was only for initial testing. Next, we can even commit these changes also. Addition controller deleted since it was only for initial testing, and then commit it, and then push it. Okay, changes are gone. Okay, now guys, are we clear with this? Whatever we did so far, are we clear with this? It's a regular setup. There is a getting started file. From there, we have just created our project, imported. We have a place where we can code. Okay, so thank you. Thank you for all confirmations. Now we have a place where we can code. Our next aim is we need to make changes so this starts behaving like config server. Okay, so what are the changes? Change number one, we need to add some pom.xml configuration dependencies needed. Okay, change number two, on the main class where your main method is available, we need to annotate something like enable config server. When you put this kind of an annotation, then it starts behaving like config server. There is logic behind it. So first, you need to have dependencies. Second, you need to do like this. Third, already Spring auto configuration is going to happen. Because of the auto configuration, we need to provide some property file changes. Nothing but in application.properties of config server, we need to provide some values. That's it. If you do these three things properly, this will start behaving like a config server. So what kind of changes are required? First, pom.xml dependency needs to be added. Second, it has to be made like this. The main class has to be made enabled with this configuration. Step number 3 is in application.property, some config server specific details. Here you can specify your details, whether you want to, where do you want to save, where you want to save properties file. Do you want it in the class path? Do you want it in the file system? Or do you want it in an external Git repo, maybe somewhere like Bitbucket? So you can make those decisions in this property file. Accordingly, it will take the effect. Okay, so let's start solving this problem one by one. Okay, you can do something very similar here, guys. Okay, what you can do is, I think, let's open everything as one place itself. We are having too many browser tabs. So this we will put here, and I will even be sharing you with this document, which you can use for later reference when you are doing some coding. Okay, Spring Cloud config. But anyways, let's try to explore it one by one. Okay, so yeah, these are the configurations, web configurations, config server. But let's try to explore it one by one. Start.spring.io. Okay, currently the latest version is 4.3, and previous to that 3.5. What we are using is 3.4 version. Okay, anyways, version related discussion we will do. But you're trying to make a Java Maven project, all this thing is fine. Let's say you want to make it a config server. You need to add a dependency of config space server, this one. Just see, as part of Spring Cloud config, you get certain dependencies for making it a config server. So just click on config server dependency. And generally, you will also have to make it a web project. So Spring Web dependency. Now, always we choose this and we go ahead with generate. But now we can use this explore option also, where it will be generating this configuration and showing us the changes here only. Okay, what kind of dependencies it has added. So we can selectively pick something from for us also. Okay. So for example, notice few very important things. In order to build a config server, we need to add this dependency. Spring Cloud config server. Okay. Second part here, second part here, this dependency will not work by itself. Let's try to put this kind of change. Spring Cloud config server we are adding. So let's go to our pom.xml, pom.xml of server. Let's do a project clean. Okay. Since we are touching the Maven, let's try to bring this down for a moment. And let's add this dependency, what we just now picked it from the start.spring.io. Notice what is happening. It is not working by default. Spring Cloud config server, it's not working by default. It is giving some error. Nothing but some version update is required. And now there are, okay, multiple ways. Now we can find a version and try to include here. But you need to understand, there are so many projects as part of the Spring Cloud. Now, everywhere they might have a versioning required. Whenever you're doing different things, you might need versioning. So what Spring team has done is they have simplified. Okay, if you're using any Spring Cloud project, you don't have to run into multiple versions of each of the project. They have given one standard configuration. Okay, so let's try to see. Spring Cloud, if you go, just see a concept of release train they are saying. What they have done is all the configurations which will be inside Spring Cloud projects, any project which is under Spring Cloud, they standardize the versioning for that using this concept called as release train. What they said, depending upon the Spring Boot version you are using, you need to set up the corresponding release train for yourself. Depending upon Spring Boot version you are using, you need to choose this correct release train for yourself. And accordingly, so one by one, you don't have to manage versions for each of the other things. So even in future, if you want to add a new dependency, let's say Spring Cloud Gateway or GCP or Kubernetes or Netflix or Open or like Ophin, Sleuth, whatever. If you want to add these other projects, you just need one version configuration. Depending upon your Spring Boot, you identify which release train it aligns to. So currently we are dealing with 3.4.x version. So accordingly, this is the one that we are supposed to use. Okay, so look at this. Currently, our Spring Boot version is 3.4.2. So for anything which is 3.4.x, you need to use this. If you expand this, there are multiple versions under that. Okay, so after 3.4.2, roughly around, this is the suitable one which comes. So anything, this works for us, this works for us, this works for us. And for these latest ones, for 3.4.2, it is not compatible. Nothing but point trying to tell you is, Spring has simplified the versioning for all Spring Cloud projects. They created a concept called as release train. Depending upon the Spring Boot you are using, you just need to add corresponding configuration. Okay, where to provide this versioning configuration? Okay, they created a separate configuration for that, dependency management. So you don't include this version along with your regular dependency tag. You need to create a new configuration, dependency management, and there you have to specify, okay, what dependencies you are dealing with, and your versioning. Just see Spring Cloud dependencies, all the dependencies of Spring Cloud, which version, you need to choose the right version which is compatible to your Spring Boot application. So that is the second change which we are supposed to do. So let's just copy this. Okay, dependency management, it is parallel to dependencies tag. So we go here, and after the dependencies tag, we can put this configuration as well. Okay, the compilation error is gone, but how? Which version has it selected? If you do click here, I'm doing Control Shift K. Just see, it is set up to this version 2024.0.1. So as a property, we have defined this version here, and then we are using it here. So this is a common practice. In the pom.xml, you can define it here, and accordingly, you can utilize it in this place. If you directly want to use the version here, sometimes people might bypass. Instead of defining it up somewhere, they might take it. But again, recommended approach is define it at the top. So you will know what kind of versions you're dealing with for different configurations. But anyways, so for ease of usage, we can just put it here. And this becomes our pom.xml changes. So what did we learn here? All Spring dependencies, they simplified the versioning using release train concept. Okay, so let's make a note of this. For all Spring Cloud dependencies, they simplified using release train concept. Depending on your Spring Boot version, you need to choose a proper release train number. Okay, and that's what it is. We can find that information in this place itself. You can, I'm just pasting this link back again. So be aware, because time and time again you might work with multiple Spring Boot versions. So you need to find the suitable one, otherwise clashing will happen. Or you have to give the same instruction to ChatGPT. This is my Spring Boot version, give me the cloud dependencies. By searching the web, it will go and get it for you. But we need to be aware of this release train concept. Okay, okay, fine. So these are the two changes required in the pom.xml. Okay, so when we make the change, let's do a quick build. So right click, run as, Maven build, clean package, and then go. Okay, some new things are also coming in the journey while we are learning Spring Cloud config. Okay, build is successful. So step number 1 is done. Pom.xml dependencies are added. Here, our main dependency is config server dependency itself, Spring Cloud config server. Okay, second thing, in the main application now, where we are doing startup, here we need to enable config server. Perfect. So we need to enable a config server here. So this is the second thing. Let's see what happens. As soon as we enable the config server, let's do a save. Let's try to run the system. Right click, run as Spring Boot app. Okay, it is failing. The reason being, the default configuration, it is trying to look for some Git location where your property files are available. So because Git is the recommended approach for saving your property files inside config server, so by default, they are saying, hey, you have not defined any Git configuration. So how are we supposed to really progress further? Okay. So for beginning with this, our initial testing we will do it is using class path. So it becomes easy for you to first understand that. And one by one, we will modify till we move our configurations inside Git repository also. So our first demonstration, config server will pick changes from class path. This is our first change to do. Okay, how do you do that? Property file needs to be modified. So let's open application.properties of config server. Guys, everybody focus. Some confusion might come because application.properties is here also in your microservice also. Now focus and alertness is required, everyone. Okay, pura ka pura, full on attention. In config server, there is a application.property. If you define some configurations there, you are discussing with the config server what setup you want. So we want some setup like this. Okay. First thing, if you want to read from class path or file system, they have given a standard profile name called as native. This is the first change which we need to be aware. Native. It's a new term, which is a defined keyword in a config server configuration. If you put it native, configuration server will understand that you are putting the files in class path or file system. So if you're putting it in Git, no, you don't have to use any native in that case. But for us, since we are first targeting with this one, our profile to be activated needs to be a native profile. Okay, so now we will change this configuration into native. Second, we will be creating one more folder inside src main resources called as config, and there we will put the files. So let us try to use GitHub Copilot and ask it to give you the configuration. Okay. My properties configuration is in class path / config location. Let's see what this guy gives. Okay. Yeah. Looks like this is the value. We can double check on the syntax. But using this another property, you are saying Spring Cloud config server native search location, and these are all keywords which config server understands. When you say class path, it searches your project class path, tries to find a folder with the name /config. So this is how the work is going to happen. So we need to give these two instructions. Okay, use the native, and for class path and file system, we need to use the native, and then we need to specify the location where the configuration is available. Okay, so let me create config folder here. Right click, new folder, config. Everything is recorded. You can go through it back and back again. But primarily, this is how our application.property is looking like. I will take a full reference of this, put it into our notes. Okay, class path setup for config server, and this is what it is. Let's just put this. Okay. Okay, changes are done. Let's try to see if the build is happening or what goes on this time. So we go back here and we try to run it once more. Right click, run as Spring Boot app. Let it happen. Okay, it did not fail this time. Let's see whether it is up and running. Yes, it is up and running. So what did we do? Step one, we exported the getting started file with basic dependencies, made it available into our GitHub Bitbucket, and made it available into our project. Step number two, we added some POM dependencies to make it a config server. Step number three, we added a annotation enable config server, which gives it capability to deal with all the server work. Next, we need to specify where are we storing. So here we say we are natively storing. Native means internally only. We are natively storing all the configurations where it is in config folder in my class path. So here we are supposed to put all the configuration files. Okay. So far this much we gave, and now the server is starting. Guys, are we clear with this so far? Everybody, are we clear with this? Team, please give a quick confirmation. Okay, Surender is clear. What about the rest? Priyanshu is clear. Okay, very good. Let's continue further. Okay, Sai, Tarun, Pallavi. Okay. Now, next, what do you think will be our next approach? These three things we did, and it is ready. We have not moved any property file there. So our next logical approach is we want to take it towards a functional system. So move the properties file from payment validation service to /config of this place. Okay. But when you are moving it, we need to rename also. We discussed while discussing the initial launch, we discussed this part. Okay, it has to go from these places. The property files needs to move here, but when you are putting there, the naming also needs to change. So two things we have to do here now. So we need to first move these files, delete it from local, delete it from client microservice, move it into the server, and then rename it. So three things we have to do. Okay. So let's start working on that one by one. Okay, guys, everybody, please put your full attention here. DevTool dependency is already added right now to config server. So whenever you do any changes, it will keep restarting. Okay, first, these are all the files. Look here. This is the client microservice, validation service. So I'm leaving the application.properties here only. If you move that one also, then 8081, where will you write it? So keep something there for that service also. So we need to move the rest of the ones. Okay. Dev, local, prod, UAT, all the environment specific properties. Let's rename this. It has a very nice shortcut. Okay, let me do it. I think ID gives a very nice way that if you select this and copy paste, it will create a new file and you have to just choose the naming here. So I think this will be easy for us. Everything in one go we can change. So we need to make it dev, but initial name will be like this. We already finalized how the name will be. Just see, I copied the Spring application name first and then -dev.property. This becomes our first property change. Like this we need to do for all. So now let's say prod. Okay, done. Next say QA. Done. Let's say local. Done. Let's say UAT. Done. Okay, we created different naming files for all of this. Super. So we copied, pasted, created different names. Next, we are supposed to move all this into config folder. With ID, you can easily do that. Select this, drag it, and place it inside config. Okay, everything is gone, and the changes are here. That is awesome. Step number 2 is taken care. What is going to be our next step? Next step we need to delete these changes from here. Microservice should not have the changes, right? That's what is movement. So what we will do is, I will just take a backup of this. If something goes wrong, we have something to fall back upon. So this we will take a backup of local file. And anyways, let's continue to delete all of this thing from the validation service. Anyways, if something happens, it is backed by GitHub, Bitbucket, so we can recover from there. So, but anyways, so we can right click and we can say delete. Gone. Client microservice may say we removed all the configuration. We created it with a different name, moved it here. Now it's available here. And when we were adding changes, so config server also started. Let's try to save this. Okay, it is coming up. Now guys, once we have moved it, I will just take a screenshot for reference how it is there. So let's put it here so you will have something to refer to. Okay, fine. This is how we have added all the files from that location to this location. Please focus. This application.property is of config server. So don't get confused. This application.property is of config server. And these things are coming from the microservice. These all things are coming from